Hello and welcome to the second lecture of the fifth module in the online course Design Thinking for Engineers. In this module, we'll be learning about prototyping. So, this module is going to have a lot of videos. The first video is going to be about rapid prototyping. The topic that are going to be covered in this lecture are prototyping and model making. In that, the first video will be regarding rapid prototyping. So, watch it, guys.
In general, rapid prototyping includes technologies and techniques that let engineers and designers create a three-dimensional scale model of their design, usually to test for form, fit, or function. The technologies include 3D printing, additive manufacturing systems, CNC machines, and injection molding systems. The selection of which approach an engineer uses depends on design needs. 3D printing began as a way to prototype quickly. The other choices, CNC machining and injection molding, have a long history in both the prototyping models and production of end-use parts. However, they both have several drawbacks. It is often expensive to create the tooling needed to make the prototype, and it can take weeks to obtain the prototype part. 3D printing, on the other hand, was developed to address these drawbacks. Depending on the prototype need, you can spend as little as $3,000 for a 3D printer, and you can build parts in hours or days depending on the complexity of the part. Plus, the cost of that one 3D printer is usually paid back in a couple of months, versus the cost of CNC and injection molding equipment. One drawback with 3D printing, though, is the prototype may not be in the engineer's desired material of choice, which can limit how much testing the engineer can do on the prototype. Materials for 3D printing are improving. In fact, 3D printing is shifting from a pure prototype solution to a volume manufacturing production approach of end-use parts. Even so, both machining and injection molding offer a wider range of materials. When deciding among the methods, one point to consider is the total number of parts to be made with or from the tooling. If you need only a few hundred, 3D printing can be the best choice. If you need thousands, then it is worth the investment of machining or injection molding to develop a long-lasting tool. 3D printing is an excellent choice when you are creating a mold and expect a number of revisions or iterations before developing the final tool. Once the tool is finalized, then machining or injection molding become cost-effective choices. For more videos like these, please visit.
So you understood what 3D printing is, right? Rapid prototyping is basically 3D printing. ஏன் வந்து 3D printing பண்ணுறோன்னு சொல்லியாச்சு, because it is cost efficient when compared to the CNC machines. உங்களுக்கு வந்து மாஸ் மேனுஃபேக்சர் பண்ண போகிறீங்க, அதாவது உங்களோட டிசைன் வந்து வெரிஃபை பண்ணியாச்சு, அப்போ நீங்கள் வந்து மாஸ் மேனுஃபேக்சரிங்குள்ளே போகலாம். அந்த ஸ்டேஜுக்கு போகிற வரைக்கும் யூ வில் பி யூஸிங் 3D printed models for very less quantities of product tools you require. Okay, so in the next one you'll be looking at prototyping and model making. This is going to be again a really good video, and I guess the English of this video is kind of overrated, so try to catch up, guys.
One of the reasons design projects are not successful is because the designer didn't make enough prototypes to test ideas, prove concepts, and highlight problems. So in this episode, we're looking at prototyping. A good prototype is not the one that looks the most beautiful or is the most well made. It's the one that answers questions and moves you forward. Often, these are the ones that don't work and are a complete disaster as much as the ones that work brilliantly. It's easy to convince yourself when a prototype doesn't work that you've failed. And even now, when they don't work, I find it frustrating. But I also love this phase because of the challenge and because every prototype I make contains clues that help me to see and fix problems and suggest lots of improvements so that my next prototype will hopefully be a few steps closer to a successful design. I've made a lot of prototypes and models. People use different terminology, but for me, models are visual. They may be scaled down, but generally, they describe the design's visual appearance, but they don't function. Prototypes show how your design works. They may not look anything like the final design, but they demonstrate how it would function. When you get a combination of the two, I would still call it a prototype, but It's like the difference between product design and industrial design. It's just not worth getting hung up on. You have to choose the right type of model or prototype for where you are in the design process and what questions you need to answer. So, depending on the design brief, you may just need a model, you may only need prototypes, but usually for each project, you will have to make both. There are two main types of product design positions. In-house designers work at companies who manufacture products, and design consultancies are external designers who design for several different companies on a contract-by-contract basis. But in both cases, it's important that you consider which prototyping and model-making techniques and materials will best help you to answer the brief. In a typical project, prototypes come before models because form often follows function. There's no point in working out the outside shape and look of something until you know how big an internal space needs to be for a circuit board or a mechanism to work. Of course, this depends on the product. If you are designing a potato peeler handle, for example, the form is the function, so the prototype could also be the visual appearance model. Look at this pair of pliers. On paper it looks good, but sketching and CAD can only tell you so much. Now, there are lots of examples of pliers already in production, and we all know how they work. It's not complicated. So with time pressures, the temptation could be to just make a quick visual appearance model, or worse, progress straight into manufacture. But a working prototype tells me how it behaves in use, and it turns out that when you close the handles together, they pinch the palm of your hand, which is really painful. You can probably imagine the trouble caused if you'd have pushed on to production with only a visual appearance model that didn't open and close. The customer complaints, the money and time lost to correct the tooling, the product recalls, it would be a nightmare. I learnt this the hard way. You have to make prototypes to test the feasibility of your ideas, to highlight problems, to use in focus groups for feedback, and to refine your designs. You're not designing for yourself, you're designing for others, so you have to give your prototypes to people to test. Put them in big hands and small hands, young, old. Find a range of people to identify problems. Prototyping can be a specialist area of design. It can take more thought and effort to work out how to design the prototype to prove your idea than the actual design itself. This prototype for a pepper grinder looks nothing like the finished design because it's just designed to test the mechanism. But by putting in a lot of thought at this stage, I can design and build the prototype to accommodate several experiments, rather than having to build a new prototype each time I want to test something else. So with this prototype, I can swap shapes in and out to test numerous angles and grating ideas, and I can watch what's happening through a viewing window. Prototypes are experiments. In science, you come up with a theory, you design an experiment, you test your theory, analyse the results, and come up with ways to improve the experiment. And prototyping is no different. James Dyson said he had to make 5,127 prototypes to get his first bagless vacuum cleaner right, but it was worth it. So as the pliers example shows, depending on the project, it's often important to make a combination of visual appearance model and working prototype to get as close to the finished design as possible. This is why today rapid prototyping is so useful, because of how accurately you can create designs from the data that will eventually go for manufacture. This process is much more streamlined, but rapid prototyping is not always cost effective or practical to use. Most companies only have access to machines with relatively small bed sizes, so it's currently not the right method to use when developing anything large. When I designed and built this prototype kitchen, for speed and cost, for me, a pine shell covered with MDF and plastic tubing was the obvious choice. As much as possible, always make everything actual size. You can't interact with a scale model in the same way. I could have saved time and materials and money making a scale model of my kitchen, but it wouldn't have highlighted any problems in use or told me half of the things I needed to know. Often the first prototypes you make are made as quickly as possible to determine if you can carry on down one avenue of exploration or identify that it's a dead end and move on. look at this chopping board. There's no point in spending a day making a full prototype like this, when 5 minutes experimenting with paper or cardboard will tell me if the mechanism works or not. Time is money, so wherever possible, prototype fast and prototype cheaply. Don't underestimate how many questions you can answer quickly with card and sellotape. Pieces of rubbish. I used card and sellotape for my first wheelbarrow prototype. Plastic bottles to work out weight distribution for a vacuum cleaner, which wasn't testing a mechanism, but prototyping user interaction to work out how acceptable or feasible a new method of doing something would be. And never forget Lego, so you don't need a lot of tools and materials to prototype. The main comment I get from students about prototyping is that they can't afford materials. When I was around 10 years old, I watched a program about making models for sci-fi films, and it showed how the rocket boosters for one model were made from the lids of toothpaste tubes. 5, 4, 3, 2, 1. For me, this was a turning point, because early on I learned that everything we surround ourselves with can be repurposed. Now I look at things differently. This isn't just a table or a chair, it's a material store, and once it's finished its role, I can see opportunities for hundreds of projects. So I don't buy a lot of materials, but I rarely pass a skip without having a peek, and friends and family by now should know not to throw anything made from wood or any broken machinery away. They should save it for me. I have boxes of bits lying around because it's always useful, and I'm forever pulling things apart to get access to the cogs and springs, the nuts, bolts, and all the materials and bits and pieces they contain. However, a word of warning, be careful when taking things apart. I was once given an old printer that I decided to take apart on my bedroom floor. Who knew in the base it had a reservoir that stored excess ink after cleaning? I was turning the cogs and I didn't realise that they were reversing a pump that was pumping ink all over a relatively new carpet. I got into a lot of hot water for that one, so be aware. Salvaging materials can be dangerous to your health. Always use the appropriate safety gear and lay newspaper down. The great thing about taking things apart is that not only do you get lots of materials for free, but you learn how things are manufactured and put together, which informs your designs, so it will make you a better designer. In the first episode on innovation, I showed this visual appearance model of a potato peeler. I made it from a strip of metal, a pen body, some sheet aluminium, and an old loyalty card, sprayed with car body spray paint. Apart from a bit of spray paint, I didn't have to buy anything to make it. I made this prototype from strips of plastic bent on a toaster, polypropylene, again from an office file, wood, and stainless steel from an old pancake flipper. This model is almost 20 years old. I made it when I was in university, which is why aesthetically it may look a bit dated, but back then it was bang on trend. It's made from MDF and turned aluminium. The handle details are pinheads, and since then the wooden dowels holding it together have shrunk and the decals have lost their stickiness. Now, I couldn't make this model now because I don't have anything like the equipment I had access to in university. So if you are in college or university, take advantage of everything available to you because you will rarely have access to so much fantastic equipment under one roof again. This is my workshop now. The work area is less than 2 meters square. I have a bandsaw, a pillar drill, a vise, and a circular saw that I have to drag outside if I want to use it. Some people assume they need a lot of tools to create prototypes, but you don't. I made this chair with just a few hand tools, no electric tools at all. So in prototyping and model making, anything goes, as long as you get the results you need. When I was young, I had no idea how to do things, and my lack of knowledge forced me to experiment. I jumped straight into prototyping, and whilst I made lots of mistakes, they led to great results that I couldn't have worked out on paper. Now I'm older, I have a much better idea of what won't work, so I spend much longer trying to work things out in my head and on paper first, to try and avoid losing time by making mistakes when I make prototypes. I put off jumping in for as long as possible. I procrastinate, which actually takes longer. This is completely wrong, but the problem is I can't go back to not having knowledge, so I must force myself to just jump in more. And this is what we all have to do. Progress the prototyping as soon as you can, because it will move your designs on faster. In the next episode, I'm going to give you more prototype making tips than you can shake a stick at. Thanks for watching. If you like this episode, please give it a...
So, how was the video? Like, I felt 100% that this guy rocks. Like, he makes use of everything that we think as crap. பார்த்தீங்களே நீங்களே அவன் வந்து நம்ம என்னெல்லாம் குப்பைன்னு நினைக்கிறோமோ அதை வச்சுக்கிட்டு என்னெல்லாம் பண்ணுறான்னு சொல்லிட்டு in the next lectures we'll have similar guys doing amazing projects, not a guy like this but even kids younger than you doing amazing projects. So see you guys till the next lecture. Bye bye.